Hi everyone, this is Zhang from Huawei UAE, and welcome to this session. And thank you for your attendance on my presentation. Today, my presentation topic is about 5G cybersecurity challenges and solution. And I'm very proud and pleasure to give a presentation in HITV CyberWeek. For the following presentation, there will be 4 parts. The first one is about the key security challenges of 5G networks. In this part, you will understand some main challenges raised in application of 5G networks and exact cybersecurity threats. Next, the second part will introduce the GSMA 5G cybersecurity knowledge base. And actually, this knowledge base can be seen as a solution base for addressing the challenges and the threats mentioned in part 1. After understanding the solution and the threats, I think it's time to introduce the cybersecurity model. This model is actually will tell us what exactly the 5G cybersecurity for our stakeholders. And this cybersecurity model is layered. It contains 3 kinds of layers representing the 5G application, network, and network equipment. Last but not least, we will introduce a top-level design principles for 5G cybersecurity. And those principles are zero trust, in-depth defense, and adaptive security, respectively. Each of them and related security assessment or security assurance standards will be specifically introduced in this part. Okay, let's go start to the first part. Nowadays, we say the usage of 5G and all 5G networks bring some changes, and those changes can be classified into 3 categories: the business changes, network changes, and technological changes. Actually, according to the excellent features of the 5G, such as enhanced mobile broadband, massive machine-type communication, and ultra-reliable low-latency communications, thousands of types of terminal devices can be connected to the 5G network or connected to the other networks. So the higher security requirements of the industry must be made. It means there are a lot of new security requirements or threats emergence, and we must be carefully consider how to address those new threats and under the new contexts. And for the network changes is actually the new architectures. The new 5G software and network deployment architectures introduce new interfaces and boundaries. The new service-based architecture, SBA, and slice architecture shall adapt to new security requirements, such as SBA-based identity authentication, slice security protection, and multi-slice risk management to prevent attacks. And also in the 5G network deployment, the user plan function on the core network in 4G era is moved from the central equipment room to the mobile edge computing in operation MEC. In this new architecture introduced new boundaries, so the extra protection should be provided in consequence. So the convergence of connection and computing also creates new security challenges. For the new technologies, the technological change, cloudification and virtualization technologies are widely used on 5G core networks, which creates security risks in the sharing and virtualization of infrastructure resources. So that in this way, the benefits is to reduce the costs of deploying physical infrastructures for different network functions. In the future, the impact of the quantum computing on traditional cryptography algorithms should also be considered to ensure network security. So from next page, I will introduce each of those changes and exact cybersecurity challenges. The first one is business changes and security challenges. Nowadays, we heard a lot of people are saying 5G enables thousands of industries and cybersecurity issues affect production and company survival. This is true. For example, for the smart industry, more and more industries are applying the telecommunication networks into their plants to increase the productivity. And also for the smart grid, in the past days, we can say some hardworking laborers doing the very dangerous portal inspection work because they must climb on the high voltage cables or the towers, which is very high and very dangerous. So today, through the 5G networks, the laborers no longer need to do that, and they just use the mainless drone to do the same thing. And also for the smart healthcare and the smart education, the remote surgery or remote education will come true, and the convenience and efficiency of our daily life will be dramatically enhanced. So the whole industry come to a common opinion. It is that security is the key guarantee for 5G industry applications. In detail, we say the industry applications are carried over 5G networks, and enterprise networks and carrier networks are converged. It means 5G networks are part of enterprise network infrastructure and needed to be protected based on the industry requirements of the enterprise. So some extra requirements, especially the security requirements for the mobile operators, must be concerned or addressed. And also we can say diversified vertical service applications and different industry requirements are increasing for the mobile network industry because they want to achieve different business objects according to use the 5G network. Therefore, different services in our enterprise have different requirements on experience and security, and the differentiated security capabilities are required. So the more the 5G networks or 5G technologies are used, the more cybersecurity requirements will be given. Will be given to the different stakeholders, not only the mobile network operators, but also some maybe application developers, service providers, and also we say the user plan function is deployed at the edge to connect to the enterprise network to carry enterprise applications and meet low latency requirements, which means the enterprise data cannot leave the campus network, for example. And this is for the business changes and the security challenges. And next, let's see the network changes and security challenges. As I mentioned previously, the most representative network changes is about the function architecture and slice. And here in this page, on the left-hand side, the first box is picked the service-based architecture, and in this figure, you can see, okay, the many network service function modules are isolated. And for example, as you can see, the access mobile function, unified data management, authentication server function, session management function, and user plan function, they are isolated. They are no longer merged together. In this way, the benefits is each function is arranged by their own interface. and the service requirement can use each of them individually and independently. So the whole cost for the service architecture will be reduced, and the service flexibility will be increased. So we say the 5G core network internal modules are reconstructed as a service-based architecture to support on-demand service deployment. This will be very effective manner. And also the slice, actually each slice can be seen as a requirement-based virtual network, and this virtual network is dedicated. This will, and slice, and each slice won't be shared with other users. So the slice enable the faster service deployment and the capacity expansion. It also reduces the costs as a result. However, the related challenges is quite straightforward and obvious. In the 5G core network, the network equipment identity authentication and message communication based on SBA must be protected, which means although we say the each network equipment or service function modules are isolated, but actually they can't be accessed without any protection or authentication and authorization. Also, for the slice, the boundaries among different slices must be isolated to prevent attacks among them. So that for example, the resource abuse based on the slice will be avoided. And also, the other very representative network changes is about the user plan function is removed from the 5G core network. And on the right hand side figure, we can see the UPF is deployed within the MEC. So we say positively, the UPF supports downsync deployment to support local traffic distribution and reduce service latency. This is quite useful, helpful, and cost beneficial. But since the UPF runs from the central equipment room to the edge equipment room or enterprise campus, the broad protection needs to be enhanced and provided. Otherwise, the safety and security of the UPF is quite problematic. Okay, the last changes is technological changes and security challenges. Actually, in the past days, I mean, in the 4G or 3G era, each hardware is dedicated for only one network equipment or the service functions. For example, on the legacy, maybe for example, the IP multimedia subsystem, and this involved the packet control is they are physically isolated, and the physical board is quite clear, and each of the hardwares are provided independently and individually. But nowadays, to increase the service effectiveness and reduce the cost, the network function virtualization is used, and it has become mandatory in 5G. Let's say this figure, there are three new existing components. The first one is the hardware basics. It means one hardware infrastructure will be provided for all kinds of network equipments or network functions. To do this, the second newly thing is introduced. This is the virtualization layer. According to this virtualization layer, those different network functions can be approached according to many virtual machines. So in order to manage them and manage those network functions, the management and orchestration components is needed. So due to those newly introduced components, the security challenges are also as introduced as a result. Let's say what they are. First, infrastructure resource sharing. The traditional physical security boundaries are broken. Resource sharing, unauthorized resource promption, application layer, data size, and image tampering, etc. And for the virtualization layer, common software as the IS layer open source software may introduce industry vulnerabilities, and open vulnerabilities are more likely to be exploited for attacks. And for the virtualized resource management, for the manual, so in virtual resource management, user spoofing and high-risk operations cause resource abuse. It means the manual will be targeted to launch the cyber attack. And also, if the orchestration process is attacked, the network equipment software package can be tampered with. After understanding those challenges, let's see the exact cybersecurity threats targeting the 5G network. And in this topology, those threats are summarized into 9 types, and they are involved into the air interface, internet, remaining, external access, transport, slice, MEC, 5G core network, cloudification, and so on. Maybe you can feel that the threat is quite more, but actually in this, for those threats, the red one are newly exist in the 5G network, and the others, the black one, have existed in the 4G network. Let's see each of those red one. For the air interface, because we know there will be many kinds of terminal devices or applications connected to the 5G network. So the DDoS attack will be a very harmful threat for the 5G network. And also due to the downsync of the UPF and the UPF and other third-party apps are deployed on the mobile edge computing, which is out of the core network or central equipment room. So the security of the connection among MEC and other network components is threatened. And for the slice, this is quite a representative and newly introduced component in 5G network. So the threat is unauthorized operating and management access, resource abusing among slices, and data leakage among slices. As for the MEC, for example, as we mentioned, the MEC's protection is independent with the 5G core network protection. So the parameter attack should be concerned, and the attacking of MEC and the attack of MEC itself, all the attack on the components involved in the MEC, for example, the attack on UPF, the third-party apps, or even the hardware and virtualization layer is quite problematic for the MEC security. And for the 5G core network threats, as I mentioned earlier, the service-based architecture is a newly targeted source. So the SBA threat is a newly threat for the 5G network. And also for the technological change, I mean the cloudification, the last part, we can see the network function virtualization threats and the container threats and the manual are all the threats involved into the cloudification threat. And this is all kinds of currently existing threats, and we also believe there will be some upcoming threats However, does that mean the 5G network is less secure than 4G, or which one is much secure, is more secure? So to answer this question, I think we should firstly review the security history of 4G. The 4G network is based on a series of security solutions and has not been attacked in a large scale in the last 10 years. So the first thing is we can confirm that 4G is secure. Okay, let's say, how about 5G? In summary, we say the 5G reuses the 4G security architecture and further enhances security for some known risks. How to understand that? We choose 6 aspects in 4G and make a comparison with 5G. Actually, they are cryptography algorithm, air interface security, user privacy protection, security policy, user authentication experience, and remaining security. By comparison, we can say in 5G there are stronger cryptography algorithm, better air interface security, stronger user privacy protection, flexible security policy, unified user authentication, and enhanced remaining security. This is because for the encryption algorithm, the 4G uses 128 bytes encryption, but 5G uses 256. And for the user air interface security, there is no integrity protection for the user plan in 4G. But this time in 5G, there is a user plan integrity protection. And for the privacy protection, the 5G uses the subscriber concealed identifier. And also in the 4G, the security policy is just a network level. It means one for all, one policy for all kinds of subscriber. But in the 5G, each subscriber is arranged with a different security policy. And also for the authentication, in the 4G network, the authentication is different for different access. But for the 5G, the whole user authentication is unified. So this is much easier to manage the user authentication and provide a more secure authentication. Last but not least, in the past days, the transmission of remaining subscriber data in 4G, this is plain text. But in today 5G, this plain text is secured, and one component is added. This is called security edge protection proxy. So among different networks, the remaining data among them are encrypted and protected. All right, after understanding the challenges and the threats, we can conclude that although the 5G is facing more risks, but we are very confident that those risks are controllable and manageable and able to be reduced. And also, in some aspects, the 5G is more secure than 4G. Okay, in this part, let's go have a look at GSMA 5G cybersecurity knowledge base. Based on industry requirements, we have seen the 5G network enables thousands of industries. So there must be many or massive number of security requirements. So GSMA oversees the cybersecurity knowledge base to provide guidance and references for ensuring mobile communication network security. This is because understanding, mapping, and mitigating those existing and upcoming security threats in an objective, speedy, and effective manner has become essential. And also, GSMA has developed the baseline security controls to help operators understand and develop their security posture to a foundation level, ensure that 5G network security is manageable and verifiable, and continuously enhances cybersecurity resilience. And also the positioning of this cybersecurity knowledge base it is to include the industry consensus threat map, mitigation strategies and measures for different roles, stakeholders, and best practices. And it is highly recommended that the stakeholders, all of network operators and equipment vendors of 5G network should use this cybersecurity knowledge base. And this cybersecurity knowledge base has been published in this year, and you can visit it on the GSMA website. Also, I would like to introduce some more details about this cybersecurity knowledge base. The first part is about who made it. Actually, the GSMA coordinates industry stakeholders such as operators, application providers, device vendors, and regulatory agencies to jointly develop a detailed 5G cybersecurity knowledge base for threat analysis and mitigation measures. That is, they call this is security codex, 5G ready. Here I show some examples here. The GSMA members participate into this fraud and security working group discussion and development. It involves mobile operators and vendors. For example, the operators from such as Vodafone, Sunrise, Orange, Telefonica, Axiata, and so on. And vendors like Huawei, Ericsson, Nokia, ZTE, Samsung, NCE, they joined. And also some security vendors also participated, such as Net Numbers, Adaptive Mobile. And also those knowledge base refer to the output of standards organizations and organizations in the industry. It means the content of this knowledge base is also based on some well-recognized and internationally accepted standards, such as, for example, 3GPP and ENISA, GSMA, PRD, and NIST. And those items are the specific referred standards. And this is who made it and what 5G cybersecurity knowledge base contains. And next, let's see the structure of the knowledge base. From bottom to the up, for the bottom layer, we see this is layer 2. It contains the 5G network typical threats. And each small box represents an exact document. For example, the FS30 real network threats and network function virtualization threats. And the other is about the 5G key security solutions. And this is the control. And according to the threats and based on the controls, the baseline security controls are defined. And also, we know the GSMA has published many other different security documents in different ways. So the overview of this 5G cybersecurity knowledge base is composed of the background and scope of this knowledge base and a mapping relationship with other documents in GSMA. So we say, so it is said, the GSMA 5G cybersecurity knowledge base builds a comprehensive 5G network security knowledge system and propose baseline security control methods based on typical 5G network threats and a series of key security solutions. All right. After looking at the overview, let's keep a closer eye on the contents. The first part is about the threats. Actually, the knowledge base comprehensively analyzes the risks, attack methods, and the impacts of mobile networks. For the comprehensive threat analysis for networks, it summarized the different fields and the threats targeting on this field. For example, the application fields, what the threat is malicious application, user compromising or theft of personal data. For the core network fields, the threat is DDoS. It's DOS attack against core network, voice call, eavesdropping, and mobile communication monitoring. And for each of these threats, such as the DOS attack against the core network, it is described specifically, and also the knowledge base show the attack methodology, how to launch. It means how to launch the attack, and also the potential impact is shown as a result of launching such an attack. And for the solution or controls, the GSMA 5G cybersecurity knowledge base gives firstly show the risk mitigation responsibilities of stakeholders. This is quite reasonable and straightforward, because when we don't understand the responsibilities of different stakeholders, it will be very, very difficult to make sure the security of the 5G. So in the knowledge base, the GSMA showed a shared responsibility. It involves the application operator and the network operators and the vendors. And it is summarized that the application security responsibility of application developer is a responsibility of application developers and service providers. The network security commonly managed, controlled, and cooperated by the mobile network operators, but some elements may also be outsourced to specialized service providers. And for the product security, this is the responsibility of the vendors. After clarifying the responsibility, it's time to show how to mitigate the attack or the threats. Here is an example of DDoS attack against the core network. So the mitigation measures include all the stakeholders, include the service provider, and what the service provider should do has been documented here, and for the operators and for the vendors, and also some references are given here to help the readers to better understand or compare the security requirements. Therefore, the GSMA believes 5G security risks can be addressed through the deployment and coordinated and verifiable security measures based on common standards. In the last part, we will give a short introduction about these common standards. After looking at the risk mitigation, let's see the baseline security control that mobile operators can consider deploying. For the controls, it involves two types. One is business controls, and the other is technology controls. I think most of us must be very familiar with the technical controls. However, this time, the business controls are given, for example, such as broad level engagement, role formally recognized security, organization policies, and so on. It means the whole security deployment is an engineer job. It involves different actors with different controls. And also for the each control module, the related team is mapped to better understand how to merge the business control and the technical controls together. Besides, a security maturity model is proposed in this space, because which can be used to assess the maturity level of information security and service control levels. The levels of level 1 to 5 represent the recognition of the control and the deployment process of the maturity level. Operators using these controls can compare the list controls with their deployed internal security control, so that they can be so that their current security controls can be improved or increased. Okay, after introducing the challenges, the solutions. Now we can have a look at what 5G security exactly means for different stakeholders. Again, this is a layer model, and this layer model is same as the GSMA's layer model. But I want to show it here to help us better understand what the 5G network security mean for different stakeholders in practice. The first layer is application security. This is for both traditional mobile and end users and vertical industries that provide or use a range of applications. And this security layer requires a collaboration among operators, device suppliers, and application providers to ensure the security of 5G networks and the users and services they support. And also the application security is not heavily dependent on the security of network types. A vertical industry must take responsibilities for the security of their solutions, protect critical assets at the application layer from network attacks, promptly detect security threats, and quickly restore basic services. And next is the network security and operating and management security. This layer is usually managed and operated by operators. They should consider network compliance and security of network design, deployment, operating and management, and operations, and continuously perform comprehensive risk assessment based on network component as well as network equipment and the architectures provided by the vendors to ensure effective management of security threats. And the last layer is for the network equipment. Actually, this layer must be provided by equipment vendors. It focuses on the compliance, security development process, and security capabilities of products. Security assessment is critical for product security. It provides a basis for assessing whether network equipment and components are designed and implemented in compliance with security requirements. And on the right-hand side, there are industry standards and methodologies to guide how to make each layer secure. And they are also well recognized and good references. So we say the 5G cybersecurity is a shared responsibility of key stakeholders, including operators, interconnection providers, equipment vendors, application providers, standards organizations, governments, regulators, each with their own clearly defined responsibilities. Those responsibilities, when fulfilled, can enable the secure deployment and the operations of 5G systems. And in this page, this is actually the exact cybersecurity modules should be concerned for the network equipment security and for the network operators. For example, the vendors must provide a trusted development environment. It must ensure the data security when the data flow are in its equipment. And for the network security, it involves networking security, RAN security, 5G core network security, and mobile edge computing security. With those security guaranteeing or assurance, the application security, such as the user data security, can be guaranteed. Okay, we are arrived at the last part of this presentation. In this part, I'm going to talk about some top-level design principles for 5G cybersecurity. The whole design principles are still based on the three-layer security model: the product security, network security and application security. And also the three main principles should be pay more attention. They are zero trust, in-depth defense, and adaptive security. For the zero trust, it means continuous evaluation and dynamic authorization in 5G network. The purpose is to defend against spoofing, evaluation of privilege. And also for the in-depth defense, the purpose is to defend against DDoS attack, malicious access, and to guarantee the encryption and anti-tampering. And for the adaptive security, it is proposed to continuous detection, especially the abnormal security event, and also do the proactive closed-up security control. Besides of them, the security standards and best practice must be referred and involved into implementing those three kinds of principles, and also to better understand how those principles are well implemented in practice. Some security governance and assessment are essential for the security evaluation. Let's see the first principle, in-depth defense. It is actually to build 4 lines of defense to establish an all-around in-depth defense system for 5G networks. Sorry, the sentence is a bit wordy. The first, actually, the in-depth defense is like an onion model. There are different layers for the protection purpose. The first one is the firewall. This is arranged at the boundary between network and other places out of network. And the second one is for the second is for the remaining security. I mean the security edge promotion, security edge protection proxy, and this is assigned between different networks. And the third layer protection is located in the network equipment. Each network equipment should not be accessed directly, and the communication among them must be protected. And the last one is for the isolation of virtual machines. In summary, we say, those 4 kinds of protection layers are broad protection, service proxy, network equipment isolation, and virtual machine isolation. The second principle is zero trust at 5G. This, as we all know, zero trust is a quite a popular IT concept in recent years, and we all think the zero trust concept is very helpful to build a more secure ICT network. So we build a zero trust model for key aspects of 5G networks. It means we just use some of the zero trust concepts to protect some critical aspects of 5G networks. Let's firstly see the left-hand side figure. This is a basic structure of the zero trust of 5G networks. In this red circle, it first includes the policy engine and the policy administrator, and those policies are designed to protect or prevent attack against the user and the administrator. And the Boston hosts firewalls, routers, and the SEEP security control program will be used as the policy enforcement point. So in this way, the zero trust at 5G is to protect the access control and according to the refined authorization of telecom users and administrators to reduce the attack surfaces. For the zero trust access, for example, the unified data management, authentication, and authorization, access mobile function access control, and also the slice access control are concerned according to zero trust. And for the administrator, it is called zero trust operating and management. The bus host authentication and authorization to the permission control, equipment management system, identity authentication, and management permission control. Here is an example of operating and management identity management of zero trust at 5G. As you can see, the device and users will be verified in different ways, and for the enforcement point, it involves IT authentication, dynamic control, and dynamic evaluation. And according to the logs and the control policies are enforced accordingly. The last one is adaptive security. It's actually continuous detection and proactive closed up based on the IPDR methodology. As we all know, the IPDR methodology is designed by the NIST. It means identification and protection, detection, response, and recovery. The purpose is to integrate adaptive security to build intrinsic 5G security capabilities and develop dynamic security solutions that are continuously optimized. Because nowadays we think the security is quite essential and critical, but what if the security is breached? What should we do? And this adaptive, so it is very needed for an adaptive security manner, and this is become another principle. So in this way, maybe the risk exposure period can be reduced from weeks to hours, and the threat detection time can be reduced from months to minutes, and also the response time will be reduced from days and to minutes. In this way, some security incident or risks can be discovered or found in time, and the service availability will be guaranteed timely. Normally it involves some intelligent analysis and automatic forensics and confirmation and policy distribution. The topology can be shown by this figure. The first part is network equipment and network protection policy. They will be enforced on threat detection based on hosts, logs, and flaws. And also those useful message or threat message intelligence can be sent to the SOC, and the network security events will be determined or identified. And then the network equipment and network response will be network response and recovery policies will be forced or triggered. As we mentioned very earlier, it is still needed to understand some security assurance or security assessment methodologies, so that we can make sure or externally say, okay, our network or our network equipments are secure. Nowadays, there are some good framework. One is NISAS and the other is called SCAS. And actually, they are mobile communication network security test specification and assessment mechanism developed by GSMA and 3GPP, and which are jointly developed by major global operators, suppliers, industry partners, and regulators. The network equipment of vendors are audited and tested by independent and authoritative third-party organizations. In detail, the NISAS covers the evaluation of vendors' product development and product life cycle. The SCAS this is the full name is Security Assurance Specification. It provides a description of the security requirements pertaining to a given network product classes. There are many benefits for the key stakeholders of applying NIST SCAS. For example, for the equipment vendors, the NIST and SCAS provides accreditation from the world's leading mobile industry representative body, delivers a world-class security review of security-related process, offers a uniform approach to security audits, and it can also avoid the fragmentation and potentially conflicting security assurance requirements in different markets. And also, for example, for the regulators, because the NIST and SCAS are developed by the mobile communication industry to prevent standards from fragmentation and maintained by industry, and continuously evolving and enhanced cost-effective, innovative, and also a low market entry barrier and promoted security benefits. So it is nowadays it is highly recommended for the industry to do the NIST SCAS application, implementation, and certification. And also, since we understand the importance and the benefits of applying the unified standards, Huawei has obtained the key assessment in the industry and is the first to complete NIST SCAS assessment. In March 2020, Huawei's 5G or 4G run was the first to pass the GSMA NIST 1.0 audit. And 2 months later, our 5G core network was the first to pass the GSMA NIST 0.1 audit. And at the end of last year, Huawei took the lead in completing the Decker SCAS 1.0 test for 5G and LTE. And we also became the first supplier that has passed the GSMA NIST assessment again. Sorry, both of them the first time. Besides, we also finished other passed the certification or assessment, such as, for example, the common criteria. In June 2020, Huawei G-Node obtained the first government accredited common criteria evaluation EAL4+ for 5G in the world, and evolved by an independent third-party lab. Here are the screenshots about those certificates. So, and here we trust. We think the trust must be based on verifiable facts, which should in turn be based on shared standards. And also, Huawei calls on the industry to work together to make positive contributions to the sustainable development of a global unified security assessment and certification system for 5G. Okay, let's make a summary about this presentation. First, ensuring the 5G cybersecurity is a shared responsibility of key stakeholders such as mobile network operators, vendors, application providers, and regulators, etc. And I think this statement has been reflected by the GSMA 5G knowledge base, 5G cybersecurity knowledge base, and also we have discussed the exact responsibilities through a layered security model. And the second point is 3 principles for top-level design of cybersecurity are consensus in the industry: in-depth defense, zero trust at 5G, and adaptive security. And also for 5G networks, NIST SCAS provides the right kind of standards. Because they are customized, authoritative, global, efficient, unified, open, and constantly evolving. And Huawei has passed a key assessment in industry and is the first to complete NIST and SCARS assessment. And that's all. Thank you for your patience and thank you for your attendance on my presentation. Bye-bye.